device's obstacle and path detection is facilitated by 3 IR sensors in the front of the car, which relay information used to control the conditional behavior of the motors. The middle sensor is used to detect the presence of an obstacle in its way, and the 2 to the left and right sense whether the car is centered on the path or skewed. A 4th sensor in the back allows the car to be powered on and off, using an IR remote control.
For actuation, the vehicle relies on 4 6-volt DC motors with integrated gearboxes, which convert electrical energy into mechanical torque suitable for ground mobility. The gear reduction in each motor increases output while reducing rotational speed, ensuring stable and controllable motion even under load. Each motor is mechanically coupled to a model wheel, forming a 4-wheel drive layout that distributes traction evenly and improves maneuverability. The motors are controlled using 2 motor drivers, allowing for bidirectional control and variable speed through PWM. This configuration enables differential drive actuation where turning is accomplished by varying the rotational velocity of the wheels on either side of the vehicle. The result is precise control over linear and rotational movement, essential for navigating our lines and with obstacles.
Our housing unit was designed in 2 parts. First, we laser cut 1/8-inch acrylic for the motor mounts and 3D printed the housing unit, which encases the components and the wiring. We incorporated various cutouts for components that needed to be outside the unit, such as our wireless sensor and obstacle detector. We also added a unit on top to hold the payload.
The remote activation feature is enabled in software by the code only running when an on variable is set equal to true. This only occurs if the remote IR sensor receives signal from the remote. The line following algorithm itself works by moving forward when there is no IR sensor input, with 16 millisecond delays per loop to control speed. The car only turns if the left or right IR sensors detect the line, each with 4 millisecond delays to allow the car to turn more cleanly. Turning is achieved by rotating the left and right sets of wheels opposite each other, and the choice of 4 motors was to enable higher power and therefore precision under heavier loads. Obstacle detection takes highest precedence in the code, and whenever an input from the front obstacle IR sensor is detected, the entire vehicle stops moving for 500 milliseconds. The vehicle continuously scans both the line and obstacle as long as it is running. The finish line is detected when both the left and right IR sensors detect input. At this point, the car stops for 500 milliseconds and promptly sets the on variable back to false. This stops the car entirely, and the line following program will only run again if it detects an additional input from the remote.